When people first hear the word infinite, it feels less like a concept and more like a whisper of mystery, something that stretches past the horizon of imagination. We say infinite when we mean boundless, when we mean too big to count, when we mean forever. But what does infinite actually mean when stripped down to the clarity of mathematics and physics? The distinction matters because how we define infinity changes how we think about the universe itself. In mathematics, infinity is not a number at all. It is not something you can reach by counting, no matter how long you go. Imagine a child stacking pebbles one after another. 10 pebbles, 100 pebbles, 1,000 pebbles. No matter how far the count rises, infinity remains beyond it. Infinity is not a destination. It is the absence of a final limit. Mathematicians treat it like a tool, a symbol that captures endlessness. They have even built hierarchies of infinities, with some infinities being larger than others, strange towers of size that defy ordinary thinking. But physics does not always allow such abstractions. In the physical world, infinity must be taken seriously. If a universe is infinite in space, that means there is no edge, no boundary, no final wall where one could point and say, here it ends. Walk in any direction, and there is always more. This is different from saying the universe is merely unbounded. An unbounded shape, like the surface of a sphere, can be finite, yet without edges. If you set off walking across the earth, you will never fall off an edge, but you will eventually circle back to where you started. Infinity in physics means not just edge-free, but endlessly extending, with no return. Already the first misunderstanding becomes clear. Many people imagine infinite space as simply a bigger version of what we already see, as though the cosmos were just stretched further than our eyes can reach. But infinity is not a matter of size, it is a matter of principle. A universe twice as large as the one we see today would still be finite. 1 trillion times larger would still be finite. Only when there is no limit at all, when doubling and tripling can go on without bound, does infinity enter the stage. This distinction between unbounded and infinite has troubled even great minds. When Albert Einstein first modeled the cosmos in the early 20th century, he tried to imagine it as finite yet unbounded, something like the three-dimensional version of the surface of the Earth. Later, discoveries of expansion forced cosmology into different directions, and the question of infinity returned. If the cosmos is flat, as many observations suggest, then perhaps it truly does go on without end. But can we ever prove such a claim? Infinity also tempts imagination into strange territory. Consider a line of numbers, stretching left and right without limit. Each number sits in its place, never ending in either direction. Now imagine galaxies instead of numbers, each galaxy with its stars and worlds, repeating forever. If the universe is infinite, then somewhere far beyond our sight, there are galaxies beyond count. And if the arrangement of matter is not infinitely varied, then perhaps those galaxies repeat, patterns echoing like mirrors in a hall with no exit. The idea that space might contain endless copies of things, perhaps even endless copies of ourselves, is born not from fantasy, but from the logic of infinity itself. But before rushing into those unsettling consequences, we must slow down and examine what infinity really implies. It is not a number to be reached, not a quantity to be stored in a container. It is an idea, slippery and powerful, that reshapes every attempt to describe reality. When applied too carelessly, it can mislead. When treated carefully, it can reveal truths that would otherwise remain hidden. And this leads us into the first great cosmic paradox. If the universe is infinite and filled with stars, why is the night sky dark? Should it not blaze with light, every direction filled with the glow of suns without end? This is the riddle once known as Olbers' paradox, a challenge that puzzled astronomers for centuries. The answer lies not only in the limits of physics, but in the limits of infinity itself. Infinity is slippery because it invites us to imagine realities beyond what our senses can handle. The human mind is trained by survival to think in limits, to see distance as a journey, and to see quantity as something to be measured and held. When we think of infinity, we try to stretch those habits like a rubber band, but eventually the band snaps. What lies beyond is not simply more of the same. it is a different kind of thing altogether. In mathematics, the shock of infinity becomes clear through paradoxes. Take the series 1 + 1/2 + 1/4 + 1/8, and so on forever. The terms shrink, yet the sum approaches 2. That is the strange power of infinity, adding up endless parts to make a finite whole. Or consider Hilbert's famous thought experiment. The hotel with infinitely many rooms, all occupied. A new guest arrives, and still a room can be found by shifting every person one door down. Even if infinitely many new guests arrive, the hotel always has space. Our intuition collapses here because in our world hotels fill up, and numbers of guests are counted, but infinity redefines these rules. Physics struggles in another way. When cosmologists say the universe might be infinite, they are not simply playing with numbers. They are proposing that no matter how far you go, there is always more. This leads to haunting consequences. If the arrangement of matter is limited by the laws of physics, then in an infinite canvas, those arrangements must repeat. There will not only be galaxies beyond our view, but galaxies exactly like our own, stars placed identically, planets identical, and perhaps people identical, walking through the same streets and speaking the same words. The thought that there are duplicates of you, existing not in imagination, but in the cold logic of space, is unsettling, yet caution is needed. Infinity in physics is not yet proven. The observable universe is finite, a bubble defined by the speed of light and the age of the cosmos. Beyond that bubble, we cannot see. The question of whether space ends or continues without bound remains open. If the cosmos is truly infinite, then all the paradoxes must be faced. If it is only very large but finite, then many of those paradoxes vanish. But science cannot simply guess. Evidence must speak, and evidence has limits. This is why it is important to separate unbounded from infinite. Imagine the surface of the Earth once more. It is finite in area, yet unbounded. You can walk without end and never fall, yet you will circle back. The cosmos could be like this, a vast, three-dimensional surface that curves back on itself. Or it could be flat and without edge, truly infinite. Observations of cosmic background radiation suggest a nearly flat geometry, which, if exact, would support infinity. But the measurement could still allow a universe that is merely unbounded, large but finite. Still, infinity creeps back into physics through time. If the universe had no beginning and stretches infinitely into the past, then every possible event must have happened an infinite number of times already. This idea collides with thermodynamics, because infinite time would allow entropy to reach its maximum, leaving a cosmos of uniform heat long ago. Yet we do not see such a dead universe. We see galaxies, stars, and complexity. This suggests time itself might not be infinite into the past, that the universe had an origin. What then of infinity into the future? Expansion seems destined to continue, galaxies drifting further until night skies grow emptier. Stars burn out, and only cold embers remain. Infinity in time means the story continues without end, even if no new events occur. It is a chilling thought, the infinite silence of eternity waiting beyond the life of stars. And yet, even with these sobering reflections, the night sky already gives us a paradox. If space is infinite and stars fill it, should not every patch of sky glow with their light? Should the heavens not shine as brightly as the surface of a star, with no darkness between? That they do not, that night exists at all, is a clue pointing toward the true structure of the cosmos. It is known as Olbers' paradox, and it forces us to confront the way infinity behaves when light and time are involved. Infinity has always been a mirror to human thought. Philosophers once wondered whether the stars were infinite in number or placed upon a crystal sphere. Mathematicians carved symbols to represent endlessness, but symbols do not carry the full burden of reality. The cosmos is not paper and chalk. It resists tidy abstractions. And yet, if the universe is truly infinite, we must accept consequences stranger than myth. One misconception is to treat infinity as simply very large. People say the universe is unimaginably big and then call it infinite. But the difference is crucial. Imagine grains of sand on Earth. There are about 10 to the power of 20 grains, a number so vast it seems endless, yet it is finite. Infinity is not a matter of scale, it is a matter of principle. No matter how large a count, infinity exceeds it. To call something infinite is to deny the possibility of completion altogether. Another misconception is that infinity must be visible. If the universe were infinite, some think we should be able to see forever, but physics blocks this with the finite speed of light. Light takes time to travel, and the universe has only a finite age. Beyond a certain horizon, light has not yet had time to reach us. Even if space extends without end, our vision does not. We live inside a cosmic bubble, and beyond its edge lies a realm forever hidden, unless the laws of nature themselves change. There is also the paradox of duplication. If matter has only a finite number of possible arrangements within a given volume, then in an infinite cosmos, those arrangements repeat. The distance to your exact twin, to an Earth with every mountain and every memory replicated, might be unimaginably far, but not infinitely far. Somewhere in the deep reaches of space, there could be another version of you reading these same words. Infinity strips uniqueness from existence, not in philosophy, but in geometry. And yet, does infinity belong in physics at all? Some argue that every infinity in science is a signal of ignorance. When equations produce infinities, physicists look for deeper theories to remove them. Black holes once seemed to harbor infinities at their centers, but many suspect a more complete theory of gravity will replace those infinities with finite structures. In quantum field theory, infinities are tamed through renormalization, a technique that replaces meaningless divergences with measurable predictions. Perhaps cosmic infinity is the same, an illusion born from incomplete knowledge. Still, infinity remains a powerful guide. It teaches humility, reminding us that the universe may not bend to human categories. It invites us to think in extremes, to stretch reason until it trembles, and to imagine consequences that feel impossible yet may be true. It is not a comfortable companion. It tells us that every possibility, every chance, every version of ourselves may be realized somewhere, somewhen. And it whispers that our sense of scale, so carefully trained on daily life, is hopelessly small compared to the canvas of reality. So we arrive at the edge of our first great paradox. If the universe is infinite and filled with stars, then the night should blaze with light, as though every point in the sky were a star's surface. The silence of darkness should not exist, but it does. The sky at night is mostly empty and black, punctuated by distant fires. This is Olbers' paradox, a riddle that unsettled astronomers for centuries. Its solution depends on the age of the universe, on the speed of light, and on the expansion of space itself. But its meaning runs deeper. It shows that infinity does not play by intuitive rules. It bends reason, it resists simplicity, and it leads us forward into mysteries that demand explanation. Thus, our journey continues, from the meaning of infinity to the paradox of darkness. The night sky becomes our laboratory, and the silence of its shadows becomes a clue. If infinity ruled unchecked, the heavens would burn with eternal brightness. That they do not forces us to confront the limits of time, the scale of space, and the fragile edge where human intuition meets the boundless unknown. The night sky seems so ordinary that most people rarely pause to wonder about its greatest secret. We look upward and see blackness sprinkled with stars, a serene pattern that has inspired poetry and myth since the dawn of language. Yet behind that familiar view lies a paradox so profound that it shook the very foundations of cosmology. If the universe is infinite, filled everywhere with stars, then why is the sky not ablaze with light? Why does night exist at all? The paradox was articulated in the 19th century by the German astronomer Heinrich Olbers, though others before him had glimpsed the riddle. It begins with a simple assumption: if space has no end, and if every line of sight eventually meets the surface of a star, then the entire sky should glow with the brightness of the Sunday. Imagine standing in a dense forest. No matter where you look, your gaze soon collides with the trunk of a tree. Now, replace trees with stars and distance with infinity. The heavens should be flooded with brilliance, yet they are not. This contradiction is Olbers' paradox. For centuries, the problem lingered. Some suggested that interstellar dust might block the light, but dust itself would heat up and radiate, filling the sky with glow anyway. Others wondered whether stars might simply fade with distance, but even faint stars would add up in infinite numbers. The logic was unforgiving. An infinite static universe should leave no room for darkness, and yet darkness is the canvas of our nights. The resolution required a new understanding of the cosmos. The first clue lies in time. The universe is not infinitely old. It has a finite age, about 13.8 billion years. That means we can only see light that has had time to travel to us since the beginning. Anything farther away than the distance light can cover in that span remains invisible, not because it does not exist, but because its light has not yet arrived. The cosmic horizon is not the edge of the universe, but the edge of visibility. The second clue is expansion. The universe is not static, it is stretching. As it expands, the light from distant galaxies is redshifted, its wavelength stretched until it slips beyond visible range. What might have been a sky blazing with light is instead diluted into the faint microwave background, a whisper of radiation that fills space but cannot be seen with the naked eye. The expansion saves the night, pushing brilliance into invisibility. Together, these two factors, finite age and expansion, dissolve Olbers's paradox. The night sky is dark, not because the universe is empty, but because the cosmos is young and growing. Infinity collides with reality, and the outcome is not eternal brightness, but a quiet darkness that cradles the stars we see. But the paradox leaves a deeper lesson. Infinity is not intuitive. Our minds picture endless stars and endless light, but the laws of physics twist that vision into something else. The universe is finite in age, bound by horizons, and reshaped by expansion. Infinity tries to assert itself, but time and motion resist. The darkness above is not a failure of infinity, but a sign that infinity behaves in ways human imagination struggles to grasp. And yet, the riddle of Olbers does more than explain the night. It invites us to think about what infinity means when applied not only to stars, but to matter, to probability, and even to ourselves. If the cosmos extends without end, then matter must arrange itself endlessly, and somewhere in the cold reaches of space, there could be other Earths, other histories, other versions of you. The mystery of the dark sky seems at first like a trick of perspective, but it is a profound key to understanding the cosmos. Olbers' paradox teaches us that infinity in space cannot be considered apart from time. If the universe had existed forever, light from every star would already have had infinite time to reach us. In that case, no matter how far away a star might be, eventually its light would arrive. Darkness would vanish. The very presence of night tells us something vital. The universe is not eternal in the past. It had a beginning. This realization aligns with the great revolution of the 20th century, when astronomers discovered that galaxies are moving away from one another, their light stretched by expansion. Edwin Hubble's observations showed that space itself is not static but dynamic, like a balloon being inflated. If the balloon is expanding today, then it must once have been smaller. Trace the motion backward, and the universe contracts toward a hot, dense origin. That origin is what we now call the Big Bang, the birth of space and time. Olbers' paradox, then, is more than a curiosity. It is a window into the history of everything. The darkness of the sky is evidence that the cosmos has a finite age. It is a silent confirmation of the Big Bang, and it is a reminder that infinity, though tempting, cannot always be applied carelessly to the real world. Still, the paradox reaches further. If the universe were static and infinite, every line of sight would indeed end on a star. But expansion changes the rules. As light travels across expanding space, its wavelength stretches, shifting colors. Light that began in the visible range slides into the infrared, then into microwaves, until human eyes can no longer see it. This ancient glow still exists. It is the cosmic microwave background, the afterglow of the Big Bang itself, bathing the universe in faint radiation. Invisible to us, it fills every direction, a hidden reminder that the paradox is resolved not by dust or imagination, but by the physics of time and motion. The lesson of Olbers' paradox is that infinity is not simple. When applied to a universe with finite age, and cosmic expansion, infinity does not give eternal brightness, but quiet shadows. The darkness we see is not emptiness. It is the visible consequence of living inside a young and evolving cosmos. Infinity and finitude wrestle in the night sky, and the outcome is the star-studded blackness that has guided travelers, inspired poets, and haunted thinkers for millennia. Yet even with this resolution, the paradox leaves a lingering unease. If the universe is infinite in extent, then although the night is dark, the number of stars is still endless. We cannot see them all, but they exist beyond the horizon, each contributing to the grand pattern of cosmic architecture. Infinity remains, hidden by time and stretched by expansion, but still present as the backdrop of existence. This mixture of finite and infinite leads us to a new set of paradoxes. If the cosmos stretches without bound, then matter must arrange itself endlessly. Galaxies repeat, clusters repeat, and perhaps even worlds repeat. Somewhere in that immeasurable distance, there could be another Earth, another set of oceans, another chain of lives. The possibility of duplicates arises not from fantasy, but from the sober logic of infinity. And if duplicates exist, then what does individuality mean? What does it mean to be unique in a universe that repeats? Thus, from the darkness of the night sky, we arrive at a deeper reflection. Infinity is not only about light, it is about identity, probability, and existence itself. The paradox of duplicates is the next chapter in this story, where the infinite becomes personal and unsettling. The paradox of darkness, though resolved by science, leaves behind echoes that cannot be silenced. When we look up, we are not seeing the full measure of the cosmos, but only the portion that has had time to send its light. The night sky is a canvas, painted by distance and time, not by infinity alone. In this sense, the paradox teaches us humility. What appears empty is not truly empty. What appears dark is not truly dark. And what seems simple hides one of the greatest proofs that the universe has a history. Yet paradoxes are not content to end neatly. Once Olbers' question is answered, another rises immediately. If the universe is infinite in space, and if matter arranges itself according to physical laws, then repetition is inevitable. This is not philosophy, but probability, stretched across eternity. In a boundless universe, every possible configuration of matter occurs not once, not twice, but infinitely many times. The mathematics cannot prevent it. Infinity allows no uniqueness. Imagine traveling far beyond the galaxies we know. Somewhere in the unreachable distance there is a star identical to the Sun, a planet identical to Earth, continents shaped in the same patterns, histories unfolding with uncanny precision. On that other Earth there is someone indistinguishable from you, reading these very words, living a life with the same memories and choices. The thought feels impossible, but it flows directly from the assumption of infinity. This idea unsettles because it dissolves individuality. We are used to thinking of ourselves as singular, but infinity erases that comfort. Every choice, every chance, every path not taken is realized somewhere else. To some, this is liberating, suggesting that no possibility is ever lost. To others, it is disquieting, reducing life to one of infinite repetitions. Probability itself loses meaning, for in infinity every event, no matter how unlikely, happens not only once, but endlessly. The night sky is dark because the universe has a finite age and is expanding, but within that darkness lies the hint of something deeper. The resolution of Olbers' paradox does not close the book on infinity, it opens the next chapter. Darkness saves us from a sky blazing with unbearable light, but it cannot save us from the implications of infinity. If space truly extends without end, then we are not unique. We are patterns repeated across the cosmos, echoes in an endless hall of mirrors. And so, from the silence of night, we move toward the next paradox. If the universe is infinite, then not only stars, but entire worlds and selves must duplicate. The question is no longer why the sky is dark, but how we understand ourselves in a cosmos where identity is not singular, but multiplied without limit. Infinity does not stop at the edges of galaxies. Once admitted into our thinking, it stretches into the heart of identity itself. If space truly extends without end, then matter has no final boundary. The laws of physics dictate how matter can arrange itself, but they do not provide infinite possibilities. Instead, they offer a finite number of combinations in any given volume. Place those combinations on an infinite canvas, and repetition becomes inevitable. The result is startling. Somewhere out there, in the unreachable reaches of the universe, there is another you. The logic is relentless. Imagine shuffling a deck of cards. There are only so many possible arrangements. A huge, but finite number. Shuffle long enough, and eventually, the same sequence must appear again. The universe works by the same principle. Atoms combine into stars. Stars gather into galaxies. Galaxies host planets, and planets give rise to life. The number of possible arrangements of atoms within a region the size of Earth is vast beyond comprehension, but it is not infinite. On an infinite stage, every one of those arrangements must repeat, not once, but infinitely many times. That includes every detail of every person, every thought, every moment. This is not a claim born of fantasy. It is the sober consequence of mathematics applied to infinity. If the cosmos extends forever, then duplicates of Earth, of human history, of you and me, are woven into its fabric. They are unimaginably far away, separated by distances so large that no light could ever carry news between us. But distance does not erase existence. Somewhere, another version of you walks through the same streets, makes the same choices, and wonders the same questions. The idea unsettles because it touches what we hold most sacred: individuality. We want to believe that we are unique, that our lives have a singular value. Infinity strips away that comfort. If everything repeats endlessly, then what makes one version of you more important than another? Does it matter which version succeeds or fails, loves or loses, if all possibilities play out anyway? Infinity collapses the idea of uniqueness into a vast echo chamber where every song is sung an infinite number of times. And yet, there is another way to look at it. If duplicates exist, then so does every dream, every possibility. The path not taken is not lost forever. It is realized somewhere else. In one world, you choose one way. In another, you choose differently. And in infinity, both choices endure. From this perspective, infinity is not cruel, but generous. It gives every possible version of you a stage, every possibility a chance to be real. Still, the notion presses against our sense of meaning. If everything happens somewhere, does anything matter here? The human mind is not built to think in infinite terms. We measure importance by rarity, by the sense that something happens once and only once. Infinity replaces rarity with inevitability. What matters then is not uniqueness, but presence. This version of you matters because it is the one you are living now, the only one you can ever experience. The others exist, but their lives are not yours. From the infinite expanse of stars, we turn inward to the infinite reflections of identity. Olbers' paradox showed us that infinity in space does not give a sky of eternal light, but a sky of darkness shaped by time and expansion. Now infinity shows us something stranger. It tells us that in a cosmos without end, individuality dissolves into endless copies. The question shifts from why the sky is dark to what it means to be human in a universe that repeats. And if duplication is inevitable, then probability itself begins to bend. In infinity, everything possible happens not once, but endlessly. What then does it mean to say something is likely or unlikely? How can we speak of chance when chance is realized an infinite number of times? The paradox of identity leads directly to the paradox of probability, where infinity stretches not only across space, but across the very meaning of possibility. Infinity is merciless in its logic. Once accepted as a real feature of the cosmos, it leaves no corner untouched. The notion of duplicates, unsettling though it may be, flows from simple reasoning. The universe operates under physical laws. Those laws determine how atoms can arrange themselves. The total number of arrangements within any finite space is vast, but finite. And when finite possibilities are repeated across infinite space, repetition is not a possibility, it is a certainty. Cosmologists sometimes describe this with an image. Picture the observable universe, the bubble of space, from which light has had time to reach us since the beginning. Within that bubble, matter can arrange itself in countless ways, but there is a maximum number of distinct configurations. Call that number unimaginably huge, yet still finite. Now tile space with an infinite number of such bubbles. Inevitably, some of those bubbles will be identical. In one of them, Earth appears. In another, an Earth exactly the same. In still another, a planet almost the same, but with one atom different, or one moment altered. The distances involved are beyond anything we can truly picture. The nearest duplicate of you, with every detail identical, might be separated by 10 to the power of 100 light years. That distance is so large that it dwarfs the scale of the observable cosmos, yet in infinity, such distances mean little. If the expanse is endless, then even events separated by impossible gulfs must still occur. Infinity does not care about distance. This thought leads naturally to a strange class of questions. If there are infinite copies, which one is the real you? The question itself may be flawed, for each version is equally real within its own world. Identity becomes not a singular line, but a branching forest of echoes. To the self inside each branch, existence feels unique. To the logic of infinity, existence is multiplied beyond measure. Probability begins to lose its meaning in such a cosmos. Ordinarily, probability measures the chance of an outcome, as if rolling dice. But if dice are rolled infinitely many times, every outcome occurs infinitely often. There is no event so rare that it fails to happen. The universe becomes a vast catalogue of every possibility realized. What then does it mean to speak of chance? When every path exists, probability collapses into inevitability. The unsettling part is that this reasoning applies not only to planets and people, but to thoughts themselves. Every idea you have, every sentence spoken, is a configuration of matter. On the infinite canvas, every configuration repeats. Somewhere, another mind is thinking these exact words, believing them to be original. The sense of originality itself dissolves in the ocean of infinity. Some cosmologists push this idea further with thought experiments such as the Boltzmann brain, a hypothetical self-aware mind that forms spontaneously out of random fluctuations. In an infinite cosmos, the probability of such a mind arising may be tiny, but not zero. And in infinity, anything not impossible becomes inevitable. The question then is not whether Boltzmann brains exist, but how many, and whether they vastly outnumber ordinary beings like us. Infinity makes even the absurd plausible, and that plausibility forces physics to confront paradoxes. This does not mean we should despair. Meaning is not erased because other copies exist. It is rooted in experience, in the here and now. Your life matters not because it is unique in the cosmos, but because it is yours. The existence of other versions does not dilute the weight of your choices. It only reminds us that infinity reshapes the context in which individuality resides. And yet the logic of duplicates cannot be escaped if the universe is infinite. Infinity ensures that everything that can happen does happen, endlessly repeated. This strange conclusion leads us directly into the next paradox. If probability loses meaning in infinity, then how do we describe reality? How can physics, a science built on prediction and likelihood, survive in a universe where chance is overwhelmed by inevitability? The thought of duplicates presses on the imagination like a weight. It is easy enough to say the universe is infinite, but far harder to accept what that means for the idea of self. If another Earth exists far beyond our horizon, and on that Earth another version of you lives the same life, is your individuality diminished? At first, it seems so. We treasure uniqueness, and infinity tears it away. But perhaps we are looking at it wrongly. Consider music. A single melody may be played countless times by countless instruments, yet each performance is real and beautiful in its own moment. The existence of other renditions does not drain meaning from the one you hear. In the same way, your life is not lessened because other versions exist. This moment, this awareness, is yours alone. Infinity does not erase it. It only means the universe is generous enough to allow endless echoes. Still, the mathematics of duplication forces us to reconsider how we think of possibility. In daily life, we measure probability by asking how likely something is to occur. A coin toss may land heads or tails, each with equal chance, but in an infinite cosmos, every toss is realized infinitely many times. Heads and tails are not outcomes to be predicted, but events that already exist in uncountable abundance. Probability loses its teeth. It no longer speaks of what will happen, only of what already is, scattered across endless space. This dissolves one of our deepest intuitions. We rely on chance to make sense of risk, of future, of decision. But if every possible future unfolds somewhere, what does it mean to choose? If another version of you makes a different choice, and both outcomes exist, is free will preserved or undermined? Infinity blurs the very concept of individuality, not only in body but in action, not only in circumstance but in choice. Philosophers wrestle with this consequence. Some argue that infinity diminishes meaning, turning life into one repetition among countless others. Others suggest the opposite, that infinity amplifies meaning by ensuring that every possibility is explored, every story told. It is not that your choices do not matter, but that all choices matter, and yours are the ones you experience. Yet physics cannot leave the question at philosophy alone. If infinity makes probability meaningless, then how can science, which relies on prediction, survive? Can equations still describe outcomes if all outcomes are guaranteed? These questions do not belong to speculation alone. They strike at the core of cosmology, at the intersection of mathematics and existence. Thus, the paradox of duplicates becomes the gateway to the paradox of probability. If infinity ensures every arrangement repeats, then probability itself seems to dissolve into inevitability. What then becomes of chance, of randomness, of prediction? How do we speak of likelihood in a universe where everything possible is already realized an infinite number of times? The night sky showed us that infinity is not intuitive. The logic of duplicates shows us that infinity is not merciful. And now we step toward a greater puzzle, where infinity threatens to unravel the very language of science. We leave behind the comfort of uniqueness and enter a landscape where probability itself becomes paradox. Chance has always been a guiding thread in human life. We toss coins, we roll dice, we speak of odds and likelihoods. Probability is the language of uncertainty, a way of measuring what might happen when the future is not yet known. But in a universe that is infinite, probability begins to unravel. If every outcome is realized somewhere, then chance does not choose between possibilities. It merely describes which branch of infinity we inhabit. The familiar logic of likelihood bends into paradox. When we say an event has a 1 in a million chance, we mean that if repeated often enough, it would occur once among a million trials. But in an infinite cosmos, a million is nothing. Every outcome, no matter how unlikely, occurs not once, not occasionally, but endlessly. In such a landscape, probability loses its teeth. Winning the lottery, surviving impossible odds, or even witnessing a miracle are not rare events at all. They are inevitable, repeated across endless worlds. The concept of chance collapses into the certainty that all things that can happen do happen endlessly. This realization shakes the foundation of physics, because physics relies on probability to predict outcomes. Quantum mechanics, for instance, describes particles not with certainties, but with probabilities, waves of chance that collapse into particular results. But if the universe is infinite, then every quantum outcome is realized somewhere. The cat is alive in one world, dead in another, and each world repeats infinitely, many times. What then does it mean to assign a probability to the cat's fate if both outcomes are already written into infinity? Probability becomes personal in unsettling ways. When you roll dice, the numbers that appear seem uncertain, yet in infinity, every possible roll is realized somewhere. In one world, the dice show snake eyes. In another, they show 12. In another, every outcome in between. You experience only one branch, but the others are not imaginary. They exist, scattered across infinity, playing out as real as the one in your hand. Chance is no longer a filter of possibility, but a sorting of perspective. Philosophers call this the measure problem, the difficulty of defining probability in an infinite universe. If all outcomes exist, how do we count them? How do we say one outcome is more likely than another when both happen infinitely many times? Without a measure, infinity flattens distinctions. The rare and the common lose meaning. Every event becomes inevitable, repeated, without end. And yet we cling to probability because it guides our choices. We speak of risks, of odds, of likely futures. Perhaps probability survives not as a cosmic truth, but as a human tool, a way of navigating our finite perspective within an infinite stage. We do not experience every branch of infinity, only this one. For us, probability describes the patterns we can see, not the totality of what exists. Still, the paradox remains. If infinity ensures that all possible futures are realized, what does it mean to predict? What does it mean to hope or to fear if every dream and every nightmare plays out somewhere in the cosmos? Probability dissolves into inevitability, and inevitability challenges the very meaning of chance. From the paradox of duplicates, we have arrived at the paradox of probability. Infinity does not merely fill space with endless stars, it fills reality with endless outcomes, and in doing so, it challenges the language of science, the logic of prediction, and the comfort of choice. Probability is one of the most useful inventions of the human mind. It allows us to tame uncertainty, to speak with numbers about events that cannot be known in advance. A doctor tells a patient there is a 1 in 10 chance of recovery. A physicist says an atom will decay with a probability of 1 in a billion in the next second. These statements are not certainties, yet they guide action, prediction, and understanding. But infinity bends this tidy framework until it splinters. In the quantum world, probability is not ignorance, but fundamental. A particle exists in a cloud of possibilities until measured, when one outcome becomes real. But in an infinite cosmos, all outcomes occur somewhere. A photon travels left in one branch of reality, right in another. An electron spins up here, spins down there. Infinity allows every possibility, and every possibility is realized. What then does it mean to assign a 50% chance if both outcomes are already guaranteed? Cosmologists face the same dilemma on a grand scale. In an infinite universe, there are not only many galaxies, but infinitely many. Within them, not only many histories, but infinitely many. Somewhere, Earth formed earlier. Somewhere, it formed later. Somewhere, dinosaurs never went extinct. Somewhere, humans never arose. To ask what is probable becomes slippery, because everything exists. The question is not whether something happens, but how often it happens compared to other events. But in infinity, counting is treacherous. Imagine trying to count even numbers and odd numbers. Both sets are infinite, yet in one sense they are equal. In another, one can seem larger depending on how you count. This is the measure problem in cosmology. If all events happen infinitely many times, how do you weigh them against each other? How do you say one outcome is common and another rare? Without a consistent measure, probability dissolves into paradox. One disturbing implication is that improbable events might dominate. Suppose the odds of a conscious mind arising from random fluctuations are unimaginably tiny. In a finite universe, such odds could be ignored. But in an infinite one, even the tiniest chance is realized endlessly. This is the riddle of Boltzmann brains, self-aware minds that blink into existence for a moment and then vanish. If the universe is infinite, such minds might vastly outnumber ordinary beings like us. If so, what does that say about our own existence? Are we typical or extraordinary? Are we the rule or the exception? Infinity pushes us into these strange corners where chance becomes certainty and rarity becomes inevitable. It does not deny the usefulness of probability in daily life, but it forces us to admit that probability may be a local language, valid only within our limited horizon. For the cosmos as a whole, infinity changes the grammar. Events are not possible or impossible, likely or unlikely. They are either forbidden by the laws of physics, or they occur without limit. This shift unsettles our sense of control. We live by weighing possibilities, by choosing paths based on their chances. But if all choices are realized somewhere, if all paths are walked in the great forest of infinity, then what does it mean to decide? Is free will preserved, or is it scattered across endless versions of ourselves, each making different moves? Infinity seems to say both things at once. From within, choice feels real. From the outside, across infinity, every choice is made. This is the paradox of probability, where chance dissolves into necessity, and where freedom and inevitability blur together until they can no longer be cleanly separated. And as unsettling as this is, the consequences reach further. If probability itself falters under the weight of infinity, then what of physics, the science that relies on it? Can the laws of nature extend coherently across an infinite stage, or do they collapse under paradox? That is the next step in our journey, from the paradox of chance to the paradox of laws themselves. Infinity does not merely stretch across space, it stretches across possibility. Probability, the very language we use to speak of chance, bends under its weight. In daily life, we flip a coin and call it uncertain. In truth, within an infinite universe, there is no uncertainty at all. Both heads and tails exist, not in imagination, but in reality, written into the endless fabric of space and time. What we call chance is only our limited view, our inability to see the other outcomes playing out beyond our reach. This collapse of probability raises questions that touch the deepest part of human thought. If all outcomes occur, then what does it mean to make a choice? When you stand at a crossroads and decide to turn left instead of right, somewhere in the boundless cosmos, another you has turned right. Both choices are real. Both lives are lived. Free will feels powerful from within, but from the vantage of infinity, choice looks like inevitability, branching into all directions. Some philosophers argue that this does not erase meaning. Each version of you experiences its own life as singular. The presence of other versions does not diminish the reality of the one you live. Probability, then, is not about what happens in the cosmos at large, but about what you can expect to experience here and now. Others argue the opposite, that infinity makes every event trivial, because nothing is unique and no possibility is denied. Between these two views lies a tension that has never been fully resolved. Science too feels the strain. Quantum mechanics, built on probabilities, predicts the likelihood of outcomes. Yet if infinity guarantees every outcome, those probabilities seem hollow. Are they merely tools for limited observers like us, while the larger reality is a deterministic infinity of all possibilities? Or does probability still carry meaning as a way of measuring relative frequencies? Even in an infinite stage, cosmologists wrestle with this, trying to define what it means to say one event is more common than another, in a universe where both occur infinitely often. The paradox of probability is not an abstract puzzle. It reaches into physics, philosophy, and human meaning. It forces us to admit that our language of chance may not survive unaltered when stretched across infinity. In its place, we face a cosmos where every path is walked, every future realized, every possibility given form. The comfort of likelihood fades into the inevitability of all. And yet, even as probability dissolves, the laws of nature remain. They are the rules by which matter and energy play their endless games. But can those laws themselves survive across infinity? Do they hold without limit, or do they break under the strain of endless extension? If infinity challenges chance, perhaps it also challenges the very fabric of physics. That is the next paradox we face, as we step from probability into the question of whether the laws of nature themselves can stand on an infinite stage. The universe is not only a stage for matter and motion, it is also a stage for laws. Gravity binds galaxies, electromagnetism lights the stars, quantum rules govern the smallest particles. These laws are the grammar of reality, the patterns that make existence intelligible. But can such laws extend across infinity? When we place physics on an endless stage, paradoxes rise like shadows. In a finite world, laws govern a limited domain. We can measure, predict, and confirm their scope. But in an infinite universe, those same laws stretch beyond any possible test. If the cosmos has no boundary, then the laws of nature must hold everywhere and forever, across endless regions we can never observe. This assumption is bold, perhaps necessary for science, but it invites troubling questions. Can we be certain that gravity works in the same way, beyond all horizons? Can we be sure that quantum rules apply without limit? Infinity forces us to confront the fact that we extrapolate laws far beyond any evidence. Entropy deepens the paradox. Thermodynamics teaches that energy spreads that order dissolves into disorder. In a finite system, entropy approaches a maximum and the system cools into stillness. But what happens in an infinite universe? If energy is spread across an infinite canvas, does entropy have a maximum at all? Or does infinity break the very logic of thermodynamics, allowing endless reservoirs of complexity? Some imagine an infinite cosmos eternally birthing stars, eternally reshaping itself. Others point out that in infinite time, even the most unlikely fluctuations must occur, creating worlds, galaxies, even conscious minds from chaos. Once again, infinity forces probability into absurdity, and physics follows. The problem of the infinite past is sharper still. If the universe has existed forever, then why is it not already in thermal death? Why do we not live in a cosmos where all gradients have flattened, all stars have died, all differences erased? The very existence of galaxies suggests that time cannot be infinite into the past. Perhaps the universe began, perhaps it emerged from nothing, or from a deeper cycle. Infinity in time seems to clash with the evidence of life and light. And yet infinity also tempts physics with elegance. Equations often prefer boundlessness. A flat universe is simpler than a curved one. An eternal cosmos is easier to picture than a creation. Symmetry extends most naturally when there are no edges, no exceptions. Infinity is seductive because it is clean, unbroken. But nature is not bound to please our sense of beauty. Nature obeys only itself. So physics on an infinite stage becomes paradoxical. Laws that work in the finite world may falter in the infinite. Entropy becomes uncertain. Probability collapses. Origins blur. We are left to wonder whether infinity is real or only a useful illusion, a mathematical trick that outpaces physical truth. And this tension drives us onward. If infinity cannot be directly observed, perhaps it can only be approached through limits, through horizons, through the edge of what can be measured. To understand whether infinity is real, we must confront the boundaries of observation itself. That is where we now turn, from the paradoxes of laws on an infinite stage to the paradoxes of cosmic horizons and limits. Infinity in physics is not only about space, it is also about time, energy, and entropy. Entropy is the measure of disorder, the tendency of systems to spread energy and even out differences. In a closed, finite system, entropy must eventually reach a maximum, leaving only uniform stillness. Stars burn out, heat spreads evenly, and no new work can be done. This is the so-called heat death, the final equilibrium of the cosmos. But in an infinite universe, what does heat death mean? If energy is spread across infinite space, then entropy itself may be infinite. A system without boundaries has no final state, no maximum to be reached. Complexity might always arise somewhere, even if most regions collapse into stillness. In such a universe, galaxies and stars could continue forming forever in scattered pockets, while other regions fade into cold emptiness. Infinity guarantees that all phases coexist. Some places burn bright, others fall silent, and both conditions exist without end. This vision unsettles because it collides with probability once more. In infinite time, even the most improbable events happen. Worlds like ours may be born not only from cosmic evolution, but also from rare fluctuations that gather order from chaos. The Boltzmann brain paradox arises here again. In an infinite future, random, self-aware minds will blink into existence an uncountable number of times. If they outnumber ordinary observers, what does that say about us? Should we not expect to be one of them? The fact that we are not may hint that infinity itself is flawed, that our models stretch too far. The infinite past brings its own crisis. If time has no beginning, then the universe has already had infinite duration to evolve. By now, every process should have already reached its end. Every star should be long gone, every galaxy dispersed, every structure erased. And yet we see a universe alive with light, with stars still forming, with galaxies still dancing in clusters. This suggests that time may not be infinite into the past. Perhaps there was a beginning, a moment when the clock started. Or perhaps the cosmos renews itself in cycles, so that entropy resets in ways we do not yet understand. The laws of physics themselves may falter under infinity. Equations that produce singularities, points of infinite density, or infinite energy, are usually taken as warnings, signs that the theory is incomplete. But many believe a deeper theory of quantum gravity will replace them with something finite. Infinities appear not as truths, but as markers of our ignorance. Perhaps cosmic infinity is the same. Perhaps when our understanding deepens, infinity will dissolve into a finite yet unbounded reality. And yet, the allure remains. Infinity offers elegance, simplicity, and symmetry. A universe without edges, without bounds, appeals to the mind. But whether nature shares that elegance is another matter. Infinity may be beautiful, but it may not be real. The tension between the infinite and the finite is not yet resolved. It is the tension that haunts cosmology, where every equation stretches into the unknown. From these paradoxes, we turn toward the limits of what can be known. The universe may be infinite, but our observation is finite. Light has only traveled so far, and we are bound by horizons. To explore whether infinity is real or illusion, we must confront those boundaries, the edges of visibility that define our cosmic stage. Infinity always seems neat on paper, but when physics tries to stretch laws across endlessness, the neatness collapses into paradox. Entropy should lead to uniform stillness, yet in infinity there is no final state. Energy should obey conservation, yet infinity raises the question of whether total energy even has meaning. The past should be infinite if time has no origin, yet the very presence of stars and galaxies tells us otherwise. Again and again, infinity pushes the laws of physics beyond their limits, showing where our understanding begins to fray. Perhaps infinity is not a feature of nature at all, but of our models. When an equation produces infinity, physicists do not accept it as reality. They see it as a sign that something is incomplete. Infinity in mathematics is a tool, but in physics it is often a warning. The singularities inside black holes, the infinite energy predicted by early quantum field theories, the infinite densities of the first instant of the Big Bang. Each of these infinities tells us the theory cannot be the final word. They are not truths. They are placeholders for a deeper law yet to be discovered. And yet, we cannot dismiss infinity entirely. The observable universe appears flat on the largest scales, and in geometry, flatness implies infinite extension. The equations that describe cosmic inflation suggest space may have ballooned into endlessness. Infinity keeps reappearing in the mathematics that describes the universe, even if direct evidence is forever out of reach. Perhaps infinity is real, or perhaps it is only the shadow of a deeper structure, an approximation our finite minds use to touch the untouchable. The question then is how to know. If infinity cannot be measured directly, can it ever be more than speculation? We are bound by horizons. The speed of light and the finite age of the cosmos confine us to a bubble of visibility. Beyond that bubble, we cannot see, cannot test, cannot confirm. Infinity may lie just beyond the edge of our vision, or the universe may curve back on itself, finite but unbounded. Both possibilities are consistent with what we observe. This is the next paradox. To test infinity, we must confront our cosmic limits. We must look at horizons not as obstacles, but as clues, the boundary between the known and the unknowable. The very darkness of Olbers' paradox told us something profound about the age and expansion of the universe. Perhaps horizons, too, will tell us something deep about the structure of reality. So physics on an infinite stage leaves us with questions more than answers. Are the laws of nature universal without end, or do they fail beyond our reach? Is entropy defeated by boundlessness, or does it still hold sway even across eternity? Is infinity a truth of the cosmos, or a mirage born of incomplete theories? These questions lead us forward to the edge of observation, to the horizons that define what can and cannot be known. From here, we step into the paradox of cosmic limits, where infinity collides not with laws, but with the very act of measurement. The universe invites curiosity, but it also sets boundaries. No matter how far telescopes peer, no matter how sensitive our instruments become, there is a wall we cannot cross. This wall is not built of matter or stone, it is built of light, of time, and of the speed limit that binds all motion. We call it the cosmic horizon, and it is the line that separates what can be known from what forever lies beyond. The horizon exists because the universe has a finite age. Light takes time to travel, and only 13.8 billion years have passed since the birth of space and time. That means light from more distant regions has not yet had time to arrive. Beyond that invisible boundary, there may be galaxies and stars and entire structures, but they remain hidden, not because they do not exist, but because their messages have not reached us. The horizon is not an edge of the universe, it is the edge of our sight. Yet the horizon is stranger still, because the universe expands. The distance to the farthest visible galaxies is not 13.8 billion light-years, but closer to 46 billion. Expansion stretches space itself, carrying galaxies away faster than light can bridge the gap. Some of those galaxies are already beyond our reach, their light frozen at the boundary. We see them not as they are now, but as they were billions of years ago. They still exist, but their present has slipped forever beyond our grasp. This creates a paradox. If the universe is infinite, then infinity lies beyond the horizon. But we can never prove it. All we know is bounded by the bubble of visibility. Our instruments can grow sharper, our telescopes larger, but they cannot pierce the limits set by light and time. The horizon is both a window and a prison, a reminder that knowledge itself has limits built into the structure of reality. For some, this limit is frustrating. How can science claim to know the shape of the whole when it sees only a part? For others, it is liberating. It means that humility is required, that certainty about infinity must always be tempered with caution. The universe may be infinite, or it may be finite yet unbounded, curving back on itself like the surface of a sphere. Both possibilities remain open because horizons prevent a final verdict. But horizons are not just barriers, they are also clues. The cosmic microwave background, the afterglow of the Big Bang, is a kind of horizon in time, the farthest surface we can observe. Its faint ripples tell us about the shape of space, the seeds of galaxies, and the conditions of the early universe. By studying horizons, we glimpse truths that would otherwise remain hidden. The very limits of sight become instruments of discovery. Infinity teases us from beyond the boundary, but we cannot grasp it directly. We can only measure what lies within our horizon and infer what might lie beyond. This tension between the finite and the infinite, between the seen and the unseen, shapes modern cosmology, and it raises a deeper question. If infinity hides behind horizons, can we ever know whether it is real? The horizon of the universe is as much a philosophical boundary as it is a physical one. We are accustomed to thinking that with better instruments, sharper telescopes, or more powerful technology, every veil can be lifted. But the cosmic horizon is different. It is not a curtain we may eventually pierce. It is written into the very structure of space and time. No matter how far science advances, there will always be regions forever beyond our reach. This limitation reshapes the way we speak about infinity. To claim that the universe is infinite is to make a statement that can never be directly proven. We cannot travel to the edge, because in an infinite cosmos, there is no edge. We cannot see the whole, because horizons prevent it. What we call infinite may be real, or it may be a convenient approximation of something merely very large. The truth is hidden behind a veil we cannot lift. This does not mean science is powerless. Horizons carry information of their own. The cosmic microwave background is a horizon in time, a faint afterglow from when the universe was young. By mapping its patterns, cosmologists can infer the curvature of space. If the universe were positively curved like a sphere, its geometry would bend in ways we could detect. If it were negatively curved like a saddle, the patterns would reveal it. Instead, the data show a universe that is nearly flat, so flat that within our horizon, it might as well be infinite. But nearly flat is not the same as infinite. Small deviations remain possible, hidden beyond our view. This is the paradox of horizons. They both conceal and reveal. They tell us what can never be seen, but they also whisper clues about what lies beyond. Through them, we glimpse the shape of space, the story of time, the seeds of galaxies. But the final answer whether the cosmos is finite or infinite remains outside their gift. Some argue that this limitation defines the very essence of science. Science is not the art of answering every question, but of answering the ones that can be tested. Infinity may never be testable, and so it may remain forever in the borderland between physics and philosophy. Yet it still shapes our thinking, because even if infinity cannot be proven, it can be imagined, and imagination has always been the first step toward discovery. The paradox of horizons leads us into deeper mysteries. If we cannot know whether the universe is infinite, then perhaps there are infinities layered upon infinities. Some theories suggest that our cosmos is not the only one, that beyond our horizon lie not only stars but entire other universes, each with its own laws and histories. The multiverse stretches the idea of infinity to its breaking point, multiplying not only matter, but reality itself. The horizon is both humbling and inspiring. It humbles us because it tells us that no matter how far we reach, there will always be more beyond our grasp. The universe hides the majority of itself forever out of view, reminding us that our knowledge is local, partial, bounded. But it inspires us because even within that boundary we have uncovered a history of unimaginable depth, from the first fraction of a second after the Big Bang to the birth of galaxies and the chemistry of life. The horizon is not the end of knowledge, it is the beginning of wonder. And wonder is exactly what infinity demands. When we speak of infinity in space, we face the impossibility of proof. We cannot see all of it. We cannot count it. We cannot touch its edges. When we speak of infinity in time, we meet contradictions with entropy, with beginnings, with the very structure of cause and effect. When we speak of infinity in probability, we lose the meaning of chance itself. In every form, infinity pushes us toward limits, and horizons are the physical symbols of those limits. They are the reminder that our reach is finite, even if reality is not. Yet horizons are not static. The observable universe grows with time, as light from ever more distant galaxies finally arrives. Our bubble of sight expands, revealing new structures at its edges. But the expansion of space also stretches galaxies away, faster and faster, until some slip beyond reach forever. We live in a cosmos where knowledge grows, but also fades. Some stars we see today will never be seen again. Their light is the last message we will ever receive. In this sense, horizons are not only boundaries in space, but boundaries in time, showing us that even infinity cannot be known all at once. So we are left with a paradox. The universe may be infinite, yet we live inside a finite bubble. We may never know whether infinity is real, yet we must still build theories that consider it. We may never prove the multiverse, yet the logic of horizons points us toward it. For if one horizon hides galaxies, perhaps another hides whole universes. If infinity stretches across space, perhaps it stretches across realities themselves. Thus, from the paradox of horizons, we move naturally to the next great mystery, the possibility of layered infinities. Perhaps our cosmos is only one bubble in an eternal froth, one page in a book without end. Beyond our horizon there may lie not only stars but whole other worlds, governed by different laws, woven into a multiverse that multiplies infinity upon infinity. Infinity in space is already a staggering concept, but modern cosmology offers something even more audacious. Not just one universe, but a multitude. If our cosmos is infinite, that is one level of vastness. But what if there are other infinities layered beyond it? Other universes with their own beginnings, their own laws, their own histories. This is the multiverse, an idea that takes infinity and multiplies it into realms upon realms. The story begins with inflation, a theory born to explain puzzles about the early cosmos. In the first fraction of a second after the Big Bang, space is thought to have expanded faster than the speed of light, smoothing the universe and explaining why it looks so uniform today. But inflation, once begun, is not easy to stop. In most versions of the theory, it continues eternally in some regions, birthing new universes, like bubbles in a boiling pot. Each bubble grows, inflates, and becomes a cosmos in its own right, with its own galaxies, stars, and perhaps its own forms of life. The multiverse is not just speculation, it is the natural consequence of inflation taken seriously. The scale of such a picture is almost impossible to grasp. Our observable universe, vast as it is, would be only one bubble among countless others, each drifting in an endless sea of creation. Within our bubble, the laws of physics take the form we know. Electrons carry a certain charge. The strength of gravity has a certain value. Atoms assemble into stars and planets. But in other bubbles, the rules may differ. Some may be sterile, lifeless, unable to form complexity. Others may host entirely different forms of matter, different chemistry, different possibilities. Infinity in space becomes infinity in laws. String theory adds another layer. Its equations suggest a landscape of possible universes, on the order of 10 to the power of 500. Each universe in this landscape has different physical constants, different shapes of extra dimensions, different properties woven into its fabric. If inflation produces bubbles and string theory provides possibilities, then the multiverse may contain not just countless copies of our universe, but countless variations as well. Infinity folds upon itself, not just in number, but in kind. This idea unsettles because it challenges the very meaning of explanation. Why does our universe have the laws it does? Why is gravity the strength it is? Why does the electron have its mass? Why is the cosmological constant so small, yet non-zero? In the multiverse, the answer may be simply that there are all possible universes, and we happen to live in one that permits life. This is the anthropic principle. We can only observe a universe compatible with our existence. Infinity, in this sense, explains not by narrowing, but by broadening. Everything exists, and we live in the version that allows observers. But does such an infinity truly exist, or is it only the shadow of our theories? Critics argue that the multiverse is untestable, forever beyond experiment. If other universes are separated from ours by horizons that cannot be crossed, then science may never confirm their existence. The multiverse may belong not to physics, but to philosophy. Yet defenders respond that even if other universes cannot be seen, the theories that predict them can still be tested. Inflation makes predictions about the pattern of cosmic background radiation. String theory, though elusive, seeks mathematical consistency. If those frameworks survive every test, then perhaps their implications must be accepted, however unsettling. The multiverse multiplies infinity. It is no longer just infinite stars or infinite space, but infinite sets of universes, infinite laws, infinite realities, layered upon one another. Some versions of the theory even suggest an infinity of infinities, hierarchies without end. We are left with a question: is reality truly so vast? Or have we simply reached the limits of imagination, where infinity becomes a placeholder for ignorance? Whether real or not, the multiverse forces us to confront our place in the cosmos. If there are countless other universes, then our own is not the only story. It is a single verse in a boundless song, a local chapter in a library with no final page. Infinity grows from the size of space to the fabric of existence itself, multiplying not only matter but reality. And with this multiplication comes a philosophical weight. If there are infinite universes, what does it mean for meaning, for purpose, for truth? If everything exists somewhere, then does anything matter anywhere? Infinity, once more, challenges not just physics, but human thought itself. The idea of a multiverse is not a single vision, but a spectrum of possibilities, each rooted in physics, yet each carrying its own version of infinity. Eternal inflation is the first great pillar. It proposes that the rapid expansion of space at the beginning of time did not end everywhere at once. In one region, inflation stopped, and a universe like ours formed. But in other regions, inflation continued, stretching space still further. Within that inflating sea, pockets constantly stop expanding and blossom into their own universes. The process never ceases. It is eternal, a cosmic fractal generating new worlds without end. To picture this, imagine a vast field of grass. Here and there, seeds sprout into flowers. Each flower is a universe, unique, and blooming, while the grass around it continues to grow. In eternal inflation, the field is endless, the sprouting never stops, and the flowers are innumerable. Our universe is one blossom among countless others, indistinguishable from afar, yet internally rich with galaxies, stars, and life. If this vision is true, then infinity is not just a property of space, it is the engine of creation itself. But inflation is not the only road to infinity. String theory, one of the leading attempts to unite gravity with quantum mechanics, paints a different landscape. In string theory, the fundamental objects are not particles, but tiny vibrating strings. The way these strings vibrate determines the properties of matter and force. But string theory also requires extra dimensions, hidden beyond our perception, curled up in shapes so small we cannot see them. The number of possible shapes for these extra dimensions is vast, and each shape gives rise to a different set of physical laws. The result is a cosmic menu with possibilities on the order of 10 to the power of 500. If inflation is the gardener that sprouts universes, string theory is the recipe book that determines their flavor. Combine the two, and the multiverse becomes a froth of endless universes, each with its own physics. Some are barren, lifeless, devoid of structure. Others may teem with galaxies and possibilities. In one, gravity may be so strong that stars collapse instantly. In another, the electron may not exist at all. In yet another, chemistry may unfold in ways so alien we cannot imagine. Infinity is no longer about repetition alone, but about variation layered upon variation. This leads to a paradox of explanation. In ordinary science, we explain the properties of the universe by deriving them from laws. But in the multiverse, the answer to why are the laws this way may be because they can be, and we live in one that allows life. This is the anthropic principle. It says that our universe is not special, it is simply one of the possible universes where observers can exist. It does not explain why gravity has its strength. It says that in many universes, gravity has many strengths, but only in a narrow range does life arise. We are here because we can be. This reasoning is unsettling because it shifts explanation from necessity to selection, from law to happenstance. The multiverse also multiplies paradoxes of infinity. If there are infinitely many universes, then every possibility is realized infinitely often. Just as an infinite universe produces duplicates of Earth and of you, so too does the multiverse. But now the duplication stretches across laws of physics themselves. Somewhere there is a universe identical to ours in every detail. Somewhere else, there is one almost identical, but with one small difference. Somewhere else, there is a universe that differs entirely, with no stars, no atoms, perhaps no time. Infinity layers upon infinity until the very idea of uniqueness collapses again, but this time on a cosmic scale. This raises deep questions of meaning. If all universes exist, does ours matter less? If every possibility is realized, what does it mean to discover truth? Science usually seeks to explain why reality is one way and not another, but in a multiverse, the answer may be that reality is every way, and we happen to inhabit one version. Explanation becomes a matter of selection, not of absolute necessity. It is a shift from certainty to plurality, from a single truth to an infinite library of truths. Critics argue that this undermines science itself. If anything is possible somewhere, then how can predictions be tested? How can we distinguish true theories from false if both find room in the multiverse? The defense is subtle. The multiverse is not a free-for-all of imagination. It is the consequence of precise theories, like inflation and string theory. These theories make predictions we can test here, within our horizon. If the predictions succeed, then their implications must be taken seriously, however strange. The multiverse, then, is not only a scientific hypothesis, but also a philosophical mirror. It forces us to question what it means to know, what it means to explain, what it means to be. Infinity has already taken uniqueness from individuals in an infinite universe. The multiverse now threatens to take uniqueness from universes themselves, and yet it may also reveal a profound unity. For if everything exists, then the multiverse is not chaos but wholeness, an endless spectrum of possibility woven into one boundless reality. The multiverse invites us to confront infinity in its most extravagant form. A single infinite universe already unsettles us with duplicates of Earth and echoes of ourselves. But a multiverse multiplies those infinities, creating not just one endless canvas, but a gallery of endless canvases, each with its own rules, its own shapes, its own stories. Infinity is no longer a straight line stretching without end. It is a branching tree, an eternal forest, a boundless library, where every book that can be written is written, and every page exists in countless variations. This vision is cinematic, but it is also deeply unsettling. In such a reality, what does it mean to search for meaning? If every possible law of physics is realized somewhere, then ours is not chosen but simply found. If every possible history plays out, then our triumphs and tragedies are mirrored and multiplied without end. The very act of asking why is transformed. We no longer ask why the universe is this way rather than another. We ask why we find ourselves in this branch, in this bubble, in this verse of the multiverse. And the answer may simply be because here we can exist. Some thinkers find this liberating. It means we need not despair at the improbability of our existence. Life may be rare, fragile, contingent, but in an infinity of infinities, it is inevitable. Somewhere, consciousness arises. Somewhere, beings look up at their skies and ask questions. We are one such case, and our questions matter precisely because they are ours. Others, however, see this as the erosion of significance. If all stories are told, then why tell ours? If all lives are lived, then why live this one? Infinity offers no easy answers. It confronts us with a mirror that multiplies endlessly, reflecting not certainty, but paradox. Philosophy has always wrestled with infinity, but the multiverse demands that physics join the struggle. Theories that predict layered infinities may or may not be right, but they remind us that infinity is not a toy of abstraction. It is a challenge to meaning itself. If reality is infinite in layers, then knowledge is always partial, explanation is always provisional, and understanding is always local. Yet this does not diminish the search. It makes it more urgent. For in an infinite landscape, the only perspective we ever truly possess is our own. So we stand at the edge of layered infinities, gazing into a hall of mirrors that stretches beyond imagination. Whether the multiverse is real or only a construct of our theories, it forces us to see the limits of human thought. Infinity is not only vast, it is alien to the way our minds work. We are creatures of the finite, shaped by survival, trained to think in boundaries and measures. Infinity asks us to abandon those habits, to stretch into concepts we can never fully hold. And so the journey continues, from the layered infinities of the multiverse to the frailty of human intuition, where the mind itself struggles to grasp what infinity truly means. Infinity is not only a challenge for physics, it is a challenge for the mind itself. The human brain evolved to count, to measure, to estimate, but only within the realm of the finite. We can picture a dozen apples on a table, 100 people in a crowd, perhaps even 1,000,000 stars in a galaxy. But when asked to imagine infinity, the mind falters. It tries to stretch familiar images beyond their scale, but they shatter under the weight of boundlessness. We mistake infinity for largeness. We imagine a very big number, and then we say it continues forever. But infinity is not just a big number. It is not a number at all. It is the absence of boundary, the refusal of completion. It is a concept that slips away as soon as we try to hold it. And yet, it is essential to mathematics, and perhaps to physics. The clash between infinity and human intuition is as old as thought itself. Mathematicians have shown how counterintuitive infinity can be. Consider Hilbert's Hotel, a thought experiment named after the mathematician David Hilbert. Imagine a hotel with infinitely many rooms, all occupied. If a new guest arrives, the hotel should be full. And yet, By moving the guest in room 1 to room 2, the guest in room 2 to room 3, and so on, we create space for the newcomer. The hotel was full, and yet it could take more. Stranger still, it can take infinitely more. The paradox is not nonsense. It is the logic of infinity, and it exposes how poorly our minds are equipped to grasp it. Infinity also comes in varieties. There are countable infinities, like the infinity of whole numbers, 1, 2, 3, and so on. But there are also uncountable infinities, like the infinity of points on a line. Between 0 and 1, there are infinitely many numbers, so many that they cannot be listed in sequence, no matter how clever the attempt. The infinity of real numbers is larger than the infinity of whole numbers, and there are infinitely many levels of infinity beyond that. To human intuition, infinity should be one thing. To mathematics, it is an endless hierarchy. This hierarchy mirrors the paradoxes of cosmology. An infinite universe is one level of vastness. A multiverse of infinite universes is another. The infinities layer and multiply, just as numbers do in mathematics. Each step takes us further from intuition, further into landscapes where our brains are ill-suited to follow. We rely on symbols, on equations, on abstraction, because imagination alone cannot keep pace. And yet, infinity fascinates us. It haunts philosophy, religion, and art as much as science. It whispers of eternity, of the divine, of unending possibility. Even when it confounds, it inspires. Perhaps this is the paradox at the heart of infinity. It is both beyond us and within us, unreachable yet irresistible. We cannot grasp it fully, but we cannot turn away. From Hilbert's Hotel to uncountable infinities, from the mathematics of the infinite to the physics of the cosmos, we see that infinity is not just a concept, but a mirror. It reflects the limits of human thought. Our minds evolved to survive in a finite world, yet we find ourselves in a reality where infinity may be written into the fabric of existence. The struggle to understand it is not only scientific, it is human, and so we are led to the final paradox. If the mind falters before infinity, can it ever know whether the universe is infinite? Or is infinity forever beyond proof, beyond imagination, beyond comprehension? To answer, we must return from the abstractions of thought to the evidence of observation, to the curvature of space and the shape of the cosmos itself. The next step is to ask, can the universe really be infinite? Or is infinity only the shadow of something finite yet unbounded? Infinity has always been a double-edged sword for the human mind. It inspires awe, yet it also defies comprehension. Our intuition is tuned to a finite world, shaped by survival on a planet with boundaries, horizons, and limits. We can imagine more and more, but only within reason. 1,000 sheep in a field, 1,000,000 grains of sand on a beach, perhaps even 1 billion stars in a galaxy. Numbers can grow larger and larger, and our imagination can stretch with them, but always in finite steps. Infinity is not just largeness. Infinity is beyond, and when we attempt to hold it, our thinking buckles. This difficulty is not new. As early as ancient Greece, philosophers puzzled over infinity. Zeno's paradoxes showed how splitting motion into infinite steps seems to prevent motion at all. Aristotle rejected the idea of actual infinity, insisting that infinity existed only as potential, the possibility to always add one more, but never as a completed totality. To Aristotle, infinity was like a road that can be walked forever, but never fully traveled. For nearly 2,000 years, this suspicion of infinity dominated Western thought. Actual infinity was considered impossible, dangerous, even impious, because only the divine could be without bound. Then, in the age of modern mathematics, infinity re-emerged. Galileo pointed out that the whole numbers 1, 2, 3, and onward without end can be paired one by one with their squares 1, 4, 9, 16, and so on. At first this seems impossible. Surely there are fewer perfect squares than there are numbers, since most numbers are not squares. Yet each square has a partner, and no number is left unmatched. This showed that infinity defies ordinary comparison. In the infinite, a part can be as large as the whole. Centuries later, George Cantor revolutionized mathematics by showing that infinities are not all equal. He demonstrated that while the infinity of whole numbers is countable, the infinity of real numbers, all the decimals between 0 and 1, is uncountable. No matter how one tries to list them, there will always be numbers left out. Between any two decimals, infinitely many more wait to be found. The infinity of real numbers is strictly larger than the infinity of whole numbers. Cantor went further, building a hierarchy of infinities, each greater than the last, a ladder with no top. This revelation was so strange that even mathematicians resisted it. Infinity was supposed to be one idea, not many. Yet Cantor proved that infinities come in layers, in magnitudes, in levels beyond imagination. It was a triumph of logic, but also a confrontation with the limits of human thought. Cantor himself struggled with depression, haunted by his own discoveries, as if gazing too long into infinity exacted a personal cost. The thought experiments that arose from these ideas remain among the most striking in all of mathematics. Hilbert's Hotel, imagined by David Hilbert, is a grand inn with infinitely many rooms, each one already occupied. When a new guest arrives, the manager should have to turn them away. And yet, by shifting the guest in room 1 to room 2, the guest in room 2 to room 3, and so on, room 1 becomes free. The hotel was full, yet it accommodated more. Stranger still, an infinite busload of guests can also be welcomed by moving each guest to a room with twice their number, leaving all the odd-numbered rooms empty for newcomers. The hotel is full and never full, complete and never complete. It is not nonsense, it is the logic of infinity, stripped of intuition. These puzzles might seem like games of mathematics, but they echo through cosmology. When we say the universe is infinite in space, we are invoking the same paradoxes as Hilbert's Hotel. If space contains infinitely many stars, then it can contain infinitely many more. If time is infinite in the past, then every event should already have happened infinitely often. Infinity destroys the logic of beginnings and endings, of more and less, of possible and impossible. The human brain rebels at this. We want infinity to behave like a large number, but it refuses. We want it to be singular, but it fractures into hierarchies. We want it to be an abstraction, but physics demands it as a reality. Infinity does not bend to us, it forces us to bend to it. And yet, this is where infinity reveals its strange beauty. It is a mirror of our limitations. It shows us that our intuitions are local tools, not universal truths. We are creatures who evolved to count food, measure distance, and track time. Infinity was never required for survival. And yet, through mathematics and cosmology, we are pulled toward it, compelled to grasp what we cannot hold. Infinity against human intuition is not a riddle to be solved, but a horizon of thought. We can approach it, circle it, describe it, but never capture it fully. And in this endless pursuit, we discover something profound. Infinity is not only out there, in space and time, it is also inside us, in the restless drive to reach beyond our limits. Infinity is not only a mathematical puzzle, it is also a human riddle. To the mathematician, infinity is an object of logic, defined and explored, with symbols that stretch beyond the limits of the imagination. To the physicist, infinity is a possibility, perhaps a reality written into the geometry of the cosmos. But to the human being, infinity is something stranger. It is both seductive and terrifying, inspiring and destabilizing. We feel drawn to it because it promises an endless horizon, but when we try to hold it, it slips away. The history of thought reveals how uneasy we have always been with the concept. Zeno's paradoxes suggested that motion itself was impossible if space and time could be divided infinitely. How can Achilles outrun the tortoise if he must first cover half the distance, and then half of the remainder, and then half of that, with no end to the halving? To us, the solution is simple. We accept that an infinite series can still sum to a finite value. But in Zeno's time, infinity seemed to paralyze reason. Even now, these paradoxes remind us that infinity disrupts the rules of common sense. In the Middle Ages, theologians debated whether infinity belonged only to God. Thomas Aquinas argued that infinity in creation was impossible because creatures are defined by their limits, while the divine alone is without limit. The very idea of an infinite cosmos was considered suspect, even heretical, because boundlessness was reserved for eternity itself. When Giordano Bruno later spoke of infinite worlds, it was a scandal not only of astronomy but of theology. Infinity has always stretched beyond science, touching what humans most revere and most fear. Mathematics in the modern era made infinity a legitimate object of study, but it did not make it more intuitive. Cantor's hierarchy of infinities, Hilbert's hotel, and the strange arithmetic of the infinite all remind us that we are dealing with something fundamentally different from the finite. Infinity cannot be counted, but it can be compared. It cannot be completed, but it can be ordered. It breaks our expectations, yet remains rigorously precise. What troubles intuition most is that infinity makes the extraordinary ordinary. In a finite world, a miracle is unique. In an infinite one, miracles are inevitable. In a finite world, rarity is meaningful. In an infinite one, rarity vanishes, swallowed by the endless repetition of possibility. Our sense of wonder is shaped by scarcity. Infinity dissolves scarcity into abundance, so complete that even the marvelous becomes mundane. This psychological unease mirrors the paradoxes of cosmology. If space is infinite, then every possible arrangement of matter exists. If time is infinite, then every history repeats. If probability stretches across infinity, then chance loses meaning. Just as Hilbert's hotel breaks the intuition of fullness, an infinite cosmos breaks the intuition of uniqueness. And just as Cantor revealed levels of infinity beyond infinity, the multiverse suggests layers of reality beyond reality. Our brains strain against concepts that were never needed for survival, but that now haunt the frontiers of science. Yet there is also a strange consolation. Infinity does not diminish our existence. It multiplies it. It does not make our choices meaningless. It frames them against a vastness where meaning must be personal, not cosmic. The uniqueness of life is not preserved by the absence of copies, but by the experience of living. Even if there are countless versions of you scattered across infinity, none of them replaces the reality of this moment, this awareness, this path through the world. Infinity strips away cosmic privilege, but it leaves untouched the intimacy of being. So the paradox of infinity versus human intuition is not a puzzle to be solved, but a condition to be endured. We cannot master infinity, but we can let it reshape how we see ourselves. It teaches us humility, because it shows us that our minds are finite. It teaches us courage, because it dares us to imagine what lies beyond comprehension. And it teaches us perspective, because it reminds us that the cosmos is not obligated to fit our instincts. This brings us to the next question, one that stands at the border of observation and imagination. If our minds falter before infinity, then what of our instruments? If our intuition resists the infinite, then what does evidence reveal? Can the universe truly be infinite? Or is infinity only the shadow of something large, yet finite? To approach that question, we must leave philosophy and return to cosmology, where observation meets theory, and where the curvature of space itself may hold the answer. The idea of an infinite universe has lingered like a shadow behind every paradox we have explored, but now we must confront the question directly: can the cosmos truly be infinite, or is infinity only an illusion of theory, a horizon that tempts us but can never be reached? This is not merely philosophy. It is a question that cosmologists have tried to answer with observation, with mathematics, with the very geometry of space itself. The most immediate clue comes from the shape of the universe. Just as the surface of Earth can be curved into a sphere, space itself can have curvature. If the universe is positively curved, like the surface of a sphere, it is finite yet unbounded. You could travel in one direction forever and eventually return to where you began, just as a ship sailing west around the Earth eventually meets its starting point. If the universe is negatively curved, like a saddle, it would still be finite within a certain scale, but its geometry would differ from what we experience locally. If the universe is flat, with no curvature, then the simplest interpretation is that it extends without bound, infinite in extent, without edge or end. Cosmologists measure this curvature by observing the oldest light in the universe, the cosmic microwave background. Tiny ripples in that afterglow reveal how light has traveled across the cosmos, bending subtly as it passed through the fabric of space. Measurements so far show a universe astonishingly close to flat. Within the precision of our instruments, space does not curve significantly at all. This suggests infinity, but it does not prove it. A sphere so large that its curve is imperceptible within our horizon would look flat to us, even if it were finite. Infinity hides behind the limitations of observation, always just beyond proof. The problem is compounded by cosmic horizons. The speed of light and the age of the universe confine us to a finite bubble. We can only see as far as light has had time to travel since the Big Bang, and that distance is about 46 billion light-years in radius. Beyond that horizon, we cannot know what lies. Infinity may stretch out endlessly, or space may fold back on itself. Our instruments cannot tell the difference. The observable universe may be only a small patch of something far larger, perhaps infinite, perhaps not. This limitation raises a profound tension. Science is built on observation and testability. To claim the universe is infinite is to claim something forever beyond direct test. At best, we can infer. At best, we can compare models. But the truth itself may be hidden forever behind horizons we cannot cross. Infinity, if real, is not only a property of space, but a property of the unknown. The possibility of a finite but unbounded cosmos is especially intriguing. Just as Earth's surface has no edge but is still finite, space itself could be curved into higher dimensions. Finite in volume, but without boundary. In such a universe, the paradoxes of infinity dissolve. There are no infinite duplicates of you, no infinite galaxies, no infinite repetition. The cosmos is vast, but not boundless. Infinity becomes a mathematical ideal, not a physical reality. And yet, the allure of infinity remains. Flatness, as observed, naturally points toward boundlessness. Inflationary cosmology, which explains the uniformity of the universe, also tends to produce universes that are infinite. Infinity keeps returning, not as speculation, but as the simplest extension of what we see. Perhaps the cosmos is infinite. Perhaps it is not. For now, the question remains suspended between theory and observation, between what can be measured and what can only be imagined. What is certain is that whether real or not, infinity is unavoidable in thought. Even if the universe is finite, the mathematics of infinity will always haunt cosmology, shaping how we think about time, space, probability, and meaning. Infinity may or may not be a property of the cosmos, but it will always be a property of the human attempt to understand it. The debate over whether the universe is infinite or finite is not settled by a single measurement, but by a tapestry of clues. One of the strongest comes from the cosmic microwave background, the faint afterglow of the Big Bang. Satellites like WMAP and Planck have mapped this ancient light with exquisite precision, tracing ripples that date back nearly 14 billion years. These ripples tell us about the density and shape of the early universe. If space curved sharply, the ripples would appear distorted. Instead, they appear almost exactly as they should in a flat universe. Flatness, however, is deceptive. A cosmic sphere of extraordinary size could appear flat to us, just as the surface of Earth looks flat when we walk across a meadow. Only by traveling vast distances, far beyond our horizon, could we detect the curve. But those distances are unreachable. We can never walk far enough across the cosmic meadow to see the arc of space. Thus, flatness suggests infinity, but cannot confirm it. The infinite and the merely immense remain observationally indistinguishable. Other clues come from the distribution of galaxies. Across hundreds of millions of light-years, the cosmos shows no sign of an edge, no sign of curvature or boundary. The structures we see, clusters, filaments, voids, continue without pattern of ending. This large-scale uniformity reinforces the idea of a cosmos without edges. Yet again, the limitation of sight remains. We cannot know if this pattern holds forever. Beyond the horizon, the cosmos may change. It may curve, close, or repeat. Some models propose a finite but unbounded universe. One possibility is a three-dimensional analog of a sphere, a hypersphere. In such a cosmos, space curves back on itself. Travel far enough in one direction, and you would return to where you began, though the journey would take longer than the age of the universe itself. Another possibility is a torus-shaped universe, where space wraps around like the surface of a donut. These models are finite, yet they lack boundaries. They resolve the paradox of infinity while avoiding edges. If the universe is finite but unbounded, the strange paradoxes of infinity may dissolve. There would be no infinite duplicates, no endless repetition, no collapse of probability. The cosmos would be vast beyond comprehension, but still contained. Our horizon would not be just a practical limit of observation, but a clue to a deeper shape. Infinity would retreat from the physical into the mathematical, existing as abstraction, but not reality. Yet the opposite possibility remains equally strong. Inflationary cosmology, which explains why the universe looks so uniform, also predicts that space may have stretched into infinity. If inflation continued just slightly longer in the earliest moments, it would flatten space beyond any curve, leaving us with a cosmos infinite in extent. In this view, infinity is not a speculation, but the natural outcome of physics. If inflation is correct, infinity may be inescapable. The tension between these possibilities reveals something profound. Cosmology does not offer final answers. It offers models, probabilities, inferences. The truth about infinity may lie forever beyond observation, hidden behind horizons. But whether real or not, infinity shapes the very questions we ask. It hovers over physics like a phantom, demanding answers, even when answers may be impossible. This is why infinity matters, not because we can prove or disprove it, but because it forces us to see the limits of science and the limits of thought. The universe may be infinite, or it may be finite but unbounded. Either way, infinity remains unavoidable. It is the horizon of imagination, the shadow of every equation, the backdrop of every story we tell about the cosmos. The question of whether the universe is truly infinite sits at the crossroads of science and philosophy. The evidence we have, like the near-flat geometry of space and the distribution of galaxies, leans toward a cosmos that could stretch endlessly. Yet the same data can be explained by a finite but unbounded shape, a hypersphere so immense that its curvature hides beyond our cosmic horizon. Infinity remains a possibility, not a proof. This uncertainty forces us into a new kind of humility. Science thrives on testable claims, but infinity taunts us with what lies forever beyond observation. Even our most powerful telescopes cannot look past the horizon imposed by the speed of light and the finite age of the cosmos. Beyond that veil, we may imagine infinity, but we cannot measure it. In this sense, infinity is not just a scientific idea, it is also a reminder of the boundaries of knowledge. Yet paradoxically, even if the universe is finite, infinity remains unavoidable. Mathematics requires it. Physics uses it. Probability demands it. Every time we imagine the cosmos larger than we can see, every time we describe time stretching into the future, every time we model the expansion of space, we are invoking infinity, whether real or metaphorical. The infinite lives in our equations, even if it does not exist in the fabric of reality. This duality between infinity as a concept and infinity as a reality defines the human relationship with the cosmos. Infinity may be an illusion of perspective, or it may be the deepest truth of existence. Either way, it cannot be ignored. To live in a universe that may be infinite is to live in the presence of endless possibility. To live in one that is finite is to recognize that infinity exists in thought, even if not in space. And so, we close this chapter on the edge of uncertainty. The universe may be infinite, or it may not. We may never know for certain. But the very act of questioning reveals something essential, that infinity is not just a matter of cosmology, but of human imagination. Whether written into the geometry of space, or only into the symbols of mathematics, infinity is part of what it means to search for truth. The next step takes us deeper into that search. For beyond the question of whether the universe is infinite, lies a more unsettling idea that infinity itself may not be singular. Theories of eternal inflation and string landscapes suggest layered infinities, a multiverse where even infinity multiplies. The paradoxes we face are not only about whether infinity exists, but about how many infinities there might be. From the very beginning of this journey, infinity has haunted every corner of the cosmos. It appeared when we asked why the night sky is dark, for an infinite field of stars should have filled it with blinding light. It surfaced when we considered that in an infinite universe, matter must eventually arrange itself into duplicates of you, of Earth, of every story ever told. It dissolved probability when we realized that in the infinite, every outcome happens infinitely many times. It stretched the laws of physics to absurdity when we asked whether energy and entropy could ever be infinite. It hid behind horizons when we measured the cosmos and found it vast but bounded by light. It multiplied itself into layered infinities when we looked at the multiverse, where eternal inflation and string landscapes generate not one infinity, but countless infinities nested within one another. Again and again, infinity appeared, not as a solution, but as a riddle. To live with infinity is to acknowledge that some mysteries may never be resolved. The universe may be infinite, or it may not. The evidence remains suggestive, not conclusive. Flatness points toward infinity, but finite models like a hypersphere remain possible. We may never see far enough to know. Infinity dangles before us, like a horizon, always retreating as we advance. And yet this lack of resolution does not weaken science, it strengthens it. For science is not about finality but about curiosity. It is not about closing questions, but about sharpening them. Infinity ensures that our questions will never run out. The very thought of infinity reshapes how we see ourselves. If the universe is infinite, then every possibility is realized. Somewhere, another you is living a slightly different life. Somewhere else, another Earth spins under familiar stars, but history has unfolded in new ways. Somewhere, perhaps, there is a cosmos so alien that even the concept of life is unrecognizable. This can feel unsettling, as if uniqueness dissolves, but it can also be liberating, as if meaning is not dependent on rarity. Life matters not because it is the only one, but because it is this one, lived here and now. Infinity also reminds us of humility. We are finite beings, bound by time, confined by horizons, shaped by evolution to navigate the finite. Our instincts are unprepared for the boundless. We stumble when we try to picture it. We falter when we try to calculate it. And yet, with mathematics and imagination, we stretch beyond ourselves. We measure the faint afterglow of the Big Bang. We trace the structure of galaxies. We speculate on the birth of multiverses. We are finite creatures, daring to approach infinite questions. That audacity is itself extraordinary. But infinity does more than inspire awe. It forces us to live with paradox. In infinity, everything that can happen does happen. In infinity, the whole can be no larger than its part. In infinity, probability breaks, uniqueness blurs, and meaning must be redefined. To live with infinity is to embrace uncertainty not as a failure, but as a truth. It is to recognize that the universe may not conform to our instincts, and that our role is not to master it, but to wonder at it. Standing beneath the night sky, we feel this paradox in our bones. The stars we see are finite, yet they hint at something endless. The silence of space feels empty, yet it holds mysteries beyond measure. Infinity is always there, woven into the fabric of reality, but also into the fabric of imagination. Whether real or not, infinity shapes the way we think, the way we dream, the way we search for meaning. Infinity is not just a scientific puzzle, it is a challenge to the human sense of meaning. For most of our history, people understood life as rare, fragile, and unique. A single Earth under a single sun, a single history, a single you. But infinity sweeps that away. In an infinite cosmos, there are not just stars without end, there are Earths without end. There are yous without end, living countless variations of your life. In such a reality, uniqueness dissolves. Identity becomes blurred. And this forces us to ask a question as ancient as philosophy itself. If everything repeats infinitely, then what makes this moment matter? Some thinkers see this as a threat. If every possible life is lived somewhere, then why does this one hold weight? If every story is told endlessly, then why tell ours? Yet others find liberation in the same vision. The meaning of life is not preserved by its rarity. Meaning comes from experience, from presence, from the living of it. Even if countless duplicates exist across infinity, none can replace the immediacy of this moment, the singular reality of this awareness. Infinity does not rob us of significance. It reminds us that significance is personal, not cosmic. Philosophy has long wrestled with this tension. Blaise Pascal once wrote of the terror of eternal silence in infinite spaces, a fear that humanity is lost in immensity. Baruch Spinoza saw the opposite, that to exist within an infinite substance was to share in the divine. For some, infinity was a void, a threat of meaninglessness. For others, it was a fullness, an embrace, a sign that reality itself was divine. This divide remains today. To some, infinity erodes purpose. To others, it magnifies it. Infinity also transforms our sense of time. In a finite span, choices matter because they cannot be undone. In infinity, every choice may be repeated infinitely many times, every outcome realized. Does this diminish free will, or does it highlight the importance of each decision? After all, even if every path is taken somewhere, this is the path taken here. Infinity does not remove agency. It reframes it. It says that our choices do not matter because they are unique, but because they are lived. Consider the metaphor of an infinite library. In its halls, every book ever written and every book never written exists. Every story told, every story untold, every variation of every word. At first, such a library seems overwhelming, even meaningless. Why read if all books exist already? Yet for the reader, the meaning is not in the library, but in the act of opening a single volume, of reading a single story, of living a single life. Infinity does not strip away narrative. It frames it, showing that in a boundless sea, each story still matters to the one who tells it. Living with infinity requires a shift in perspective. We must abandon the idea that meaning depends on rarity or uniqueness. Instead, meaning arises from intimacy, from presence, from the small scale of lived experience. We are not diminished by the thought of infinite copies. We are affirmed because no infinity can erase the reality of this moment. The universe may be infinite, but your awareness remains finite, here, unrepeatable in its immediacy. And in this recognition lies a strange kind of peace. Infinity will always be beyond our grasp. It will always multiply, always expand, always stretch beyond our understanding. But we do not need to master it to live with it. We need only to acknowledge it, to let it expand our sense of wonder, and to continue the search without expecting an end. For in infinity, the search itself is endless. Infinity is a horizon that never ends. To live with it is to live with questions that expand faster than answers, with mysteries that deepen even as they are explored. Science approaches infinity with equations, measuring cosmic microwave ripples and mapping the geometry of galaxies. Philosophy approaches infinity with paradox, testing the boundaries of thought. Poetry and art approach infinity with metaphor, trying to clothe the unimaginable in images. Each way of seeing touches part of it, but none contains it. Infinity is not an answer we discover. It is a landscape we inhabit. Standing beneath the stars, we feel the pull of that landscape. The sky is dark, yet scattered with ancient light. Each star is finite, each galaxy limited, yet together they suggest something endless. The silence of space feels like emptiness, but behind it is a grandeur too vast for comprehension. Whether the universe is truly infinite or only unimaginably large, To us, the difference is invisible. Infinity may be real, or it may be illusion, but in either case, it has become part of our imagination, a backdrop against which we measure the scale of existence. Infinity also teaches humility. For every step we take toward understanding, infinity pushes the horizon further. Our minds, shaped for survival, falter before the boundless. We divide space and find it divisible still. We count, and numbers stretch without end. We measure, and discover we can never measure all. Yet this limitation is not defeat. It is the essence of wonder. To confront infinity is to recognize that knowledge is always unfinished, that discovery is always beginning. It also teaches courage. For if infinity multiplies every possibility, then despair is only one of its faces. Another face is hope, the recognition that possibility itself is endless. Every question we ask, every experiment we conduct, every story we tell, adds to the human attempt to navigate the infinite. We will never finish, but we will always begin. In this way, infinity is not a threat, but an invitation. And so we return to the night sky. It is the same sky that puzzled ancient philosophers, that inspired medieval theologians, that drove modern scientists to build telescopes and theories. It is the same sky that stirs us now, with questions about meaning, about identity, about existence. Infinity shines in that sky, not as a fact proven or disproven, but as a presence felt. It whispers that the universe may have no end. It reminds us that even if it does, imagination does. To live with infinity is to live with wonder unbroken by certainty. It is to accept paradox without resolution, to cherish meaning without uniqueness, to search without expecting closure. Infinity is not an answer. It is a mirror, reflecting the limits of the mind and the vastness of the cosmos. It is the echo of questions that will never end, and the light by which we ask them. And if the universe is infinite, then so are the questions it inspires.